All right, this video is about chapter 8.6, which is solving radical equations. So here are some steps that are described. Hopefully, as we walk through some examples, they'll make sense to you. I know that I have a radical equation because I have an equal symbol that tells me it's an equation. I have a square root symbol in this case, that's a radical. And so I'm going to be solving for what the value of x is. Now, one of the most important things to remember is that we are going to have to check for potential extraneous solutions. Remember that word has the beginning extra, right? So whenever you raise an equation to a power, you are creating potential extraneous solutions. So in this case, we are going to have to check our answers to make sure they work. And so let's see what would happen. So step one on the steps that are listed up above is that you're going to isolate the radical on one side of the equation. So this is my radical, and so I want to get that by itself. I see that there's a 3 on both sides, so I'm going to subtract 3 from both so I can get my radical alone. So now, in order to get rid of a square root, I'm going to square, and if I do that on the left, of course, I have to do it on the right. And when I do it on the left, when you square a square root, you are left with what's inside of the radical, and that's equal to 25. Now I have an equation. This is a linear equation, so I solve that by getting x by itself. I add 3 to both sides, and I get x equals 14. Again, I have to check. You are welcome to show me the work of you checking, which is kind of a nice place to start. But the key is that you remember that you need to. So this is 3 plus 2 times 14 is 28, minus 3 is 25. So this is 3 plus 5 equals 8, which is true. So therefore, x does equal 14. Okay, same strategy. We see that it's an equation. I see that I have a root. I get my root by itself, in this case, by adding 5 to both sides. I want to undo the square root, so I'm going to square both sides. On the left, I'm left with 4x plus 1. On the right, I'm left with 25. I solved for x by isolating the value of x, and then I have to check 4 times 6 plus 1 inside the square root. This is 24 plus 1 is the square of 25, and that's 5 minus 5, which does in fact equal 0. So therefore, x equals 6 is a solution. Okay. Now this one's a little bit different because in this case I have a square root, but notice that the other term includes an x. So things are going to be a little different, but the strategy will still be the same. I'm going to get the radical by itself by subtracting 3x from both sides. And again, the way that I get rid of the square root is by squaring. Now notice these parentheses matter. On the left, when I square root, I'm left with, I square a square root, I'm left with what's inside. On the right, remember when you square something, you are multiplying it by itself. Negative 3 times negative 3 is positive 9. X times x is x squared. So on this side, I have 9x squared. Now notice this solving is now a little different than what we had a minute ago because this is a quadratic equation. So I can't just isolate x. I need to solve it like a quadratic equation. Our way to solve that is by getting everything onto one side so that my equation is equal to 0. Notice that I moved these both to the right because I like to have my coefficient of x squared to be positive. I'm going to invite you to pause the video to check on this factoring, but in fact this factors like this. This is the zero product property, so either 9x plus 1 equals 0 or x plus 1 equals 0. This is 9x equals negative 1, so x equals negative 1/9, and this is x equals negative 1. Again, I invite you to pause. It turns out that both of these work when you check it in the equation that we started with. So again, same idea as what we did before, except that now the expression that is isolated that's needed to move to isolate the square root includes an x. All right, and number 4, similarly, notice that we have two terms that are not inside the radical. So we're going to move 5 to both sides by adding it. Again, I'm going to, in order to get rid of a square root, square it. On the left side, squaring a square root cancels each other out. On the right side, again, always helpful to remind yourself that when you square something, you are multiplying it by itself. I think that most of us, if we wrote it like this, would remember we have to FOIL, whereas it's a very common mistake when you see it just like this to think that you can distribute that exponent. You can't, because there's addition inside. So when I FOIL what's on the right, I get x squared plus 10x plus 25. Again, this is a quadratic equation. We solve those by thinking about factoring. So I'm going to subtract x and subtract 7 from both sides. I like my x squared to be positive. And so when I do that, I get this quadratic equation. Because it's equal to 0, I'm going to see if I can factor. I see that there are two numbers that multiply to be 18 and add to be 9, and those are 6 and 3. This would be x equals -3. This would be x equals -6. If you plug in -6, because again, we have to check for extraneous solutions, notice what happens. -6 plus 7 minus 5 equals -6. This is the square root of 1. This is 1 minus 5 equals -6. That does not equal -6. Therefore, this is not a solution. If we plugged x equals -3, I'd get the square root of 4 minus 5 equals -3. 1 minus 5, that's 2 minus 5 equals -3, which is true. So x equals -3 is the solution. All right, this is a similar example. I'm going to get my square root by itself by subtracting 3 from both sides. Now I want to get rid of the square root, so I square. On the left, I have 5x minus 1. On the right, remember, we have to FOIL. So I get x squared minus 6x plus 9. I want to prepare to solve this, so I want to get everything on one side so it's equal to 0. I'm going to move everything to the right so that x squared can stay positive. I have x squared minus 11x plus 10 equals 0. I look for two numbers that multiply to be 10 and add to be -11. Those are -1 and -10. X equals 1, x equals 10. Now I have to look to check my answers. Square root of 5 times 1 minus 1 plus 3 equals 1. This is the square root of 4 plus 3 equals 1. 2 plus 3 equals 1. That's not true, so x cannot equal 1. Square root of 5 times 10 minus 1. This is the square root of 49, which is 7. 7 plus 3 equals 10. That is correct. So notice it's not visibly obvious when a solution will work and when it will not. You just have to appreciate the fact that if you had an equation where you squared or raised both sides to a power, you have potentially created extra solutions, so you always have to check, okay? This one is slightly different because notice that the kind of root that I'm taking here is a third root, but the idea is still the same, which is that I'm going to isolate the root by subtracting 5 from both sides. The only thing that's different now is that in order to get rid of a third root, you're going to raise it now instead to the power of 3. So on the left side, a third root being raised to the power of 3 is still going to cancel. On the right side, when you have -2 times -2 times -2, you are going to end up with -8. I subtract 1 from both sides, and I get -9. To check, cube root of -9 plus 1 plus 5 equals 3. This is the cube root of -8. Cube root of -8 is -2, and that is correct, so x equals 9 is a solution. All right, and finally we'll do one more example here. We're back to a square root. Notice that my root is already isolated, so I can square both sides. On the left, the square root and the square will cancel. On the right, I need to FOIL. This is a quadratic equation. I'm going to solve it by getting it equal to 0. I like my x squared to be positive. So when I do this, I get x squared minus 3x. And notice that when I subtracted the 4, those cancel out. Remember, our first step we always use when we're trying to factor is to look for a GCF. I see that x can divide into both of these terms. So if I factor out an x, I can see that either x equals 0 or x equals 3. I'm going to check my solutions. This is the square root of 4 minus 0 equals 0 minus 2. Square root of 4 equals negative 2. 2 equals negative 2 is not true, so x cannot equal 0. Make sure that you indicate to me that you know that that's not a solution. I don't want you to just get to x equals 3. I need you to show me I knew that x equals 0 was a potential solution, and I have eliminated it. Now when I plug in x equals 3, this is the square root of 1 equals 1. That is true, so x equals 3 is a solution.